Today's lesson about maximum flow and the fourth Fulkerson method. A flow network, is a direct graph where each edge, also called an arc, has a certain capacity which can receive a certain amount of flow. The flow running through an edge must be less than or equal to the capacity. Each edge in the flow graph has a certain flow and the capacity specified by the fraction adjacent to each edge. Initially, the flow through each edge is zero and the capacity is a non-negative value. So for this for a flow graph, we are going to use Ford Fulkerson algorithm, and to find the maximum flow and the minimum cut as a byproduct, the Ford Fulkerson method repeatedly finds the augmenting paths through the residual graph that augments the flow until no more augmenting paths can be found. And I am going to explain it through animation. So step 1, at zero capacity links to pair one-way edges. So here directed graph and has vertices and the values that we are going to add capacity. So as you see near with edges we have another edges which has zero value. It's our capacity links. So from this we are going to from source to sink. So in ordinary in flow graph we have source and the sink vertices in the beginning and in the end. So here source is S and the sink is D. So we choose path SPK. No, DMK PS, and we and here minimum value is 6 and it will be our flow. So flow equals to 6 units. After this we are going to update the residual network due to flow F. So current here total 6 flow and we update it. Then if we are going to use some method on DMBS, our maximum flow will equals to 2 and the total flow will be 6 plus 2. So it's a method for Ford Fulkerson. And about Java example. So we are going to use for here linked list and the total number will be equals to 6. And then we are going to use BFS so breadth first search. In breadth first search we have matrix, source, and second it's sink and also parent. And then we have Ford Ferguson, which will find maximum flow. Then we are going to show it in main. So in BFS we have a Boolean matrix, which then we start a loop, and our and at first we are going to give visited as a false, so it's not visited, and they create our queue, um, and we are going to mark first source as visited. So standard BFS loop and then we have here a loop which if you find a connection to the sync node, and then there is no point in BFS anymore. We just have to set its parent and they can return true. So okay, like this. Mm, so we set that parent equals to new value and it's visited. We didn't reach sync in BFS starting from source, so return false. Okay, we already talking about BFS in last topics, so I'm going to main part, and it's a Ford Fulkerson method. So in Ford Fulkerson method, we have three parameters. It's matrix, source, and T sync vertices. So create a residual graph and fill the residual graph with given capacities. In the original graph as a residual capacity and residual graph. So okay, in the residual graph where G graph ij indicates residual capacity of H from I to J if there is an H. If I graph ij is 0, then there is not. Okay, at first create graph, then fill graph with u and the v values, and create parent, and for default value of maximum flow is equal to 0. So while BFS graph is parent, so while there is path from source to sink, find the minimum residual capacity of the edges along the path filled by BFS. Or we can say find the maximum flow through the path found. Okay, for while it's equal to sink and it's not equal to source, we're going to give value that v it's equal to parent value, and we are going to change upgrade u and say that path flow now it's equal to minimum value from between path flow and the graph. So we upgrade path flow and give minimum value. Update residual capacity of the edges and the reverse edges along the path. So here we are going to upgrade it. Add path from the to the overall flow. So okay. In the here graph, and then we are going to print here. So maximum possible flow, it will be 20. So for this graph, and it's all. Thanks for attention.